I wanted to take a moment and just go over a little bit of a more tricky problem, and also a problem that's going to look specifically at how many atoms or molecules of a certain element, and not just looking at a compound overall. So hopefully this video is helpful in understanding a little bit more about how to use stoichiometry more in depth. So we're going to be looking at this big problem here. This is in your note packet on the mole mass and number of molecules page. It is page 7 if that's helpful to you. And we're going to go over this together. So first let me read it. Isopentyl acetate, which is C7H14O2, is the compound responsible for the scent of bananas. Interestingly, bees release about 1 microgram, which is equivalent to 1 × 10⁻⁶ grams of this compound when they sting. Which is crazy to me that bees are releasing the scent of bananas. The resulting scent attracts other bees to join the attack, which again is fascinating. How many molecules of isopentyl acetate are released in a typical bee sting, and how many atoms of carbon are present? So in this problem, we have 2 separate problems we're trying to solve. We're trying to find how many molecules of isopentyl acetate are released in the sting, and how many atoms of carbon specifically are present. So we're going to attack both of these problems. Hopefully we already have a basic understanding of how to do the first one, but let's definitely learn how to do the second one. So I'm going to make myself a little bigger, and I've outlined this problem behind me on the board. So I've noted that isopentyl acetate is C7H14O2. A bee sting releases this much of it. So how many molecules are released in a typical sting? It's telling us that we have this many grams usually in a typical sting. So in this problem, we're trying to go from grams to molecules. And remember, molecules can also be replaced with the word atoms. So we're going to go from grams to atoms. Remember, we cannot go directly from grams to atoms. We have to go from grams to moles and then moles to atoms. So this is going to be a 2 to 3 step problem. So let's start with this value given here, because we're always going to start with our given. 1 × 10⁻⁶ grams, and that's a measure of C7H14O2. And we're trying to convert this into atoms of isopentyl acetate. So to go from grams to atoms, we must first go to moles. So to find moles, we need to find our molar mass of this value. So I'll find our molar mass over here. So our molar mass of this, you see this? Perfect. Our molar mass of this compound, we need to take C, which is 12.01, times 7, H, which is weighted at 1.01 times 14, and O, which is weighted at 16 times 2. And we add these all together to get about 130.18 grams. So that's our molar mass we're going to be using. And since we have grams of C7H14O2 on the top, we know we need grams of C7H14O2 on the bottom, because we have to have a unit on top and bottom to cancel our units. Our value going here then is that 130.18 grams, and that's going to be equivalent to 1 mole of C7H14O2. After this step, we have grams on the bottom and grams on the top, so we're able to cancel that unit. And we're left with moles. And we know we can go right from moles to atoms. So we have moles of C7H14O2 on the bottom, and we always have 1 mole. And that's going to be equal to 6.02 times 10 to the 23rd molecules. Remember, that's Avogadro's number, so we can cancel our moles. And we're left with molecules of what we're looking for, because remember, we were looking for molecules. So we're going to multiply across the top. Remember to put these values that are in scientific notation in parentheses, and divide by 130 basically. And hopefully you should get the answer when you plug it into your calculator of 5 times 10 to the 15th molecules of isopentyl, sorry. It's a funky word. So that's part 1 of this problem, of asking us how many molecules are released in a typical bee sting. However, we aren't done yet. The second part of the problem asks how many atoms of carbon are present. So we found the total molecules, but we're looking specifically for atoms of carbon. And notice we have C7. So what we're going to do here is use this answer as the given for our next problem. So 5 times 10 to the 15th molecules of C7H14O2. Okay, and that's going to be on the top. Okay, and this many molecules we know is equal to 1 mole of C7H14O2. And 1 mole of this, notice, is equal to 7 moles of carbon because there's 7 carbon molecules in that compound. Okay, I know it seems a little wonky that 1 mole of a compound is equal to 7 moles of something because that doesn't make sense. But basically what this is saying is 1 mole of carbon is multiplied by 7, so there's 7 moles of individual carbon in here, which makes sense because 1 mole of carbon is 12.01, and then if we put these all together, we have 1 mole of this compound. Remember, the mole is not a for sure unit, but instead a relationship between numbers. Okay, so we have moles on the bottom, molecules, sorry, on the bottom, molecules on the top. I'm sorry, I just confused you a lot. This should say 1 molecule. Okay, 1 molecule of C7H14O2 has 7 moles in it. Okay, so molecules of carbon in it. I just confused the heck out of you, and I apologize. So this should be 1 molecule of C7H14O2 and 7 molecules of carbon in that 1 molecule. We're going to just multiply these straight across to get 4 times 10 to the 16 molecules of carbon. Okay, so let's say there was only 2 molecules of carbon in this compound. You'd multiply by 2. If we're looking for hydrogen, you'd multiply by 14. So hopefully that kind of makes sense. If it doesn't, let me know. Again, sorry I completely messed this up. Hopefully you understand it now, but I don't know how to edit videos well enough to fix this, and I'm not starting over. All right, bye.